everybody, thanks for watching. Now, the reason why I wanted to do this video on quantum physics is to show you how complicated we and the universe really is. Having this basic understanding of quantum mechanics will help you to understand and help you to take your mind off of what you can actually see and to focus on how we and the universe actually works on a quantum level. Now, this video will be a lot different from your usual videos on quantum mechanics and quantum physics. And if this is the first time you have seen my videos, then I suggest you go back and watch previous videos because I do things a lot different from most people. Now, most religious people will look out into the universe. They will look at the sun, the moon, the stars. They will look at the people, and they will say that, religion must be real because we exist. Our religious doctrines tell us, how we got here, who put us here. But once we begin to understand quantum physics, we will see that human beings are a lot more complicated than simply taking dust from the ground. Now, when we look at every physical thing in the universe, we see that everything is made up of atoms, electrons, protons, and neutrons. When we look around at our world, we can see that we have things that are made of liquid or solid. If you put your hands on the surface of a liquid, we can see that our hand will actually pass through a liquid. But if you put your hand on the surface of a solid, say like a wall, then your hand will not pass through a wall. But when we examine this interaction on a quantum level, that's exactly what should happen. Our hand should actually pass through the wall. So how is that possible, and why doesn't that happen? Now, believe it or not, atoms are actually 99.9% of empty space. So that means that the atom is almost made entirely of empty space. So why is it that we don't just, fall through the floor? Why don't our hands simply pass through the wall? Now, the whole thing is when we look at atoms, when two atoms come into close contact with each other, the electrons actually exchange particles called photons. The exchange of these particles causes the electrons to push away from each other. This sensation is what we know as touching. Now, this all happens on a microscopic level because atoms are ultra small, but we can actually go even smaller. Now, when we examine the atom, we see that it is an electron orbiting around a nucleus of protons and neutrons. Now, when we look at protons and neutrons, we see that they are made of tiny bits of matter called quarks. Now, when we look into quantum chromodynamics, we see that, these quarks are basically the building blocks of protons and neutrons. Now, when we go even smaller from quarks, we get into what is known as string theory. Now, string theory deals with tiny vibrating strings of energy that combine all of the forces in nature, all of the basic particles, and their interactions. Now, the thing is, when we ask ourselves, if everything in the universe is made up of atoms, then why is it that, everything isn't, the same? Why do things look different? Why do we have liquids and solids? Why do we have things that are shiny and things that are, dark? What is going on with that? So the whole thing is when we examine string theory, we see that it is these tiny vibrating strings of energy that determines the properties of a particle or the mass of a particle. So basically the difference between us and everything in the universe depends on how these strings vibrate. There are four interactions that particles go through: strong nuclear interaction, weak nuclear interaction, electromagnetic interaction, and gravitational interaction. Now, the problem is gravitational interaction conflicts with the other three interactions. Strong and weak nuclear interaction and electromagnetic interaction are all explained by quantum physics. Gravitational interaction is explained by Einstein's theory. So string theory is basically combining all four interactions so that they unify, so that they make sense. And what string theory tells us is that our universe is made up of multiple dimensions. And depending on how these strings vibrate, they can be detected in three-dimensional space as matter, light, or gravity. Now, three-dimensional space is our dimension. We basically have three spatial dimensions: up, down, left, right, back, forward. So it's how these strings vibrate that is determining whether something is matter or energy. Now, the thing with physics and science is getting the math correct, getting the equations to make sense. Now, if your math is wrong and the equations don't equate, then your experiments cannot be proven as physics or science, and they fall in that whole realm of philosophy. Sure, it sounds all theoretical, but it cannot be proven to with a mathematical certainty. Now, this is the problem that we run into with string theory. String theory does not make sense in a universe that only has 3 spatial dimensions. So in other words, the math does not equate in a universe that does not have multiple dimensions. Now, we know the strings are there, but the math does not add up in a universe without multiple dimensions. Now, physicists ran into a problem when they discovered 5 major string theories with 5 different sets of equations that contradicted each other about the same thing. Now, in 1994, a man named Edward Witten, along with a few other scientists, came to the conclusion that these 5 different equations were not wrong at all, that they were in fact talking about the same thing, but from different perspectives. So think about it as looking into a funhouse mirror. When you look into a funhouse mirror, you get multiple views about the same person. So what these physicists were able to do was combine all 5 major theories into one theory called M theory. Now, no one knows officially what the M stands for, but most physicists believe it stands for membrane, since M theory tells us that these strings are really one-dimensional slices of a 2-dimensional membrane vibrating in an 11-dimensional space. So, I know it all sounds confusing, but it's going to make a lot of sense as we go on. Now, understand, even if all of the math is correct, even if all of the equations make sense, a theory is still a theory until it is tested and proven to be true. So now with string theory and M theory talking about extra dimensions, of course, this theory has to be tested to be proven true. So now this brings us into modern day and this. Yes, CERN in Geneva, Switzerland, where they have built a large hadron collider where they will send particles in near the speed of light in hopes that 2 particles will collide, and this collision will generate enough energy that will force the debris from our dimension to force the particle into another dimension. So what they will do is they will measure the amount of energy before the collision, and if there is less energy, then this means the dimensions are actually there, that they really exist. Now, I said everything I just said in this video. I gave you the whole history, talked to you about particles and electrons and atoms, M theory and string theory, and told you all of this to get you to understand what CERN was really about. It's done, it's over with, we are still here. Now, instead of these people doing actual research and telling you everything I just told you, they decided to put all of these spooky videos on YouTube to scare people, telling people that CERN was going to open up a dimension where demons were going to come out and suck our blood, and Satan was going to come into the world through this dimensional portal, and none of that happened. Now, the whole thing is we have to realize that were there actually physicists in Geneva, Switzerland doing an experiment that would risk the entire planet, don't you think that other governments would have came and rallied to stop them? Now, remember, these strings we are talking about are ultra small, much smaller than an atom. In fact, if an atom was the size of the sun, then these strings would still be smaller than an eyelash. So now, if ultra small strings and multiple dimensions were not, weird enough, it's about to get a lot more weirder. Now, when we start to examine the actions of atoms further, then things get a little bit spooky. Now, anybody who has studied physics knows all about the double slit experiment. Now, this is the double slit experiment. Now, you have 2 guns here. And what you would expect is if we fire these 2 guns, then the bullets will go through the slits and they would land on the wall in the position of the slits. So where the bullets will go through the slits at, we expect them to be in that same spot on the back of the wall. Now, the whole thing is, if we do this experiment, this will indeed happen. But if we change the bullets into, let's say, electrons, then the experiment will, yield the same results. The electrons will go through the double slits. They will land exactly where we expect them to land. Now, this is the weird part. When we observe this experiment, the electrons do exactly what we expect them to do. They go through the double slit, they land in that position on the wall. Now, the weird thing is when these electrons were fired without the physicists observing the experiment, they came out as waves. They traveled through the double slit and they landed at multiple positions along the wall. Now, this wave is called a probability wave. And at the height of these waves is where the electron will probably land along the wall. Now, the whole thing is, once they observe the experiment, the wave function collapses and the electrons turn back into particles. And we can understand that they're going to either land on this side and this side along the double slits. So they tried another experiment. And what they did was they didn't observe when the particle was fired and the electron came out as wave. It traveled through the double slit as a wave. And what they did was right before the wave hit the wall, they observed the experiment, and sure enough, the wave turned back into a particle. And it landed exactly where we think it would land. So what happened was the electron actually went back through time to right before it came out of the gun, turned back into a particle, went through the experiment as a particle, right before it was observed by the physicists, and landed right where we thought it would land along the double slit. Now, if that is not weird, I don't know what is. So basically, when we observe the experiment, we get particles. When we don't observe it, we get waves. Now, the same thing happens with light as well. Light travels in little particles called photons. Now, physicists have done experiments where light travels as waves. So, which is it? Particles or waves? Now, that depends on what you observe the experiment with. Now, light can either travel in particles or it can travel in waves, depending on what you use to observe it. So, if you observe it with one thing, it will be a particle. Another thing, it will be a wave. It all depends on how it's observed. So, this is a lot of spooky action, weird action that we get when we start dealing with light and particles, when we start dealing with atoms, waves, when we start dealing with the electron. There's a lot of action, a lot of weird things that take place that involves observation. So what are we talking about here? Consciousness. These experiments could not handle consciousness. In fact, they were altered by the scientists in the room observing the experiment. So consciousness itself changed the wave function into a particle. Now, since these experiments are dealing with, the atom, the electron, it's dealing with the very nature of our physical reality, what these experiments have in fact proven is our consciousness can affect our reality itself. So when physicists observe these experiments, their observation caused the waveform to change into a particle, and it forced the particle to choose a definite location instead of a probable location. So the implications for this are huge. So now let's go back and look at string theory. These strings vibrate at different frequencies, and depending on how they vibrate, it will determine whether something is matter or gravity or light. So now, what is it that makes these strings vibrate? And it's their intrinsic nature that these strings actually vibrate. But what else can we look to find frequency and vibration? And that is sound.